Burton.
Thank you. So, yeah, it's a silly title. Hopefully I can sort of try to explain what I mean by this. Keyboard? Okay. So I am a system administrator, and like pretty much all the system administrators I know, I enjoy beer. Beer time, then, is the amount of time that we have to enjoy beer. Unfortunately, as a system administrator, the things that decrease beer time are things like complex and non-standard systems that are difficult to maintain. These types of things are bad. And so what is a complex and difficult to maintain system? In my opinion, it's anything that doesn't behave like the things that you're used to. So we live in a world of package management, pip, apt, yum, standard commands like from systemd, configuring things from standard paths, and dependency management through package management. Galaxy doesn't do any of those things in the ways that you would expect as a sysadmin. So why is it this way? There's actually a few reasons. One is that Galaxy is 10 years old at this point, or around 10 years old, and some of the choices that we made back then were pretty common at the time. And then since a lot of stuff was added to Galaxy over time, it became more and more difficult to sort of modernize the way that we installed. So that's one reason, but another, in fact, is that Python packaging itself has had a very tumultuous history, which I'll give you a short history lesson on. So distutils is the standard Python setup.py mechanism for installing packages. That's been around forever. 2003, the cheese shop came along, which was what later became PyPy. 2004, you got setup tools, which was a third-party improvement to distutils. It brought with it its own packaging format, eggs, and the easy install command. Then you got pip in 2008. Setup tools was forked into distribute because there was a disagreement, and then merged back in later when they smoothed things over. And then there was a huge effort to try and improve Python's standard packaging library in Python 3.3. They did a ton of work on it, and then decided it was no good and got rid of it. Finally, the Wheel project came along in 2012. Meanwhile, Galaxy has existed since 2006, and we're watching all this turmoil, and it was never really clear exactly what the correct way forward was until really around 2014, when that turmoil started to settle down. So obviously now the way that you do things is with pip install, or if you're more system-minded, you probably want to be able to install with apt or yum. And so that's the goal here. To accomplish that goal, there are two steps. The first is going to be to update Galaxy's ancient dependency handling system, which was based on Python eggs. So if you have installed Galaxy prior to the beginning of this year, you've dealt with Galaxy eggs. And if you're an administrator, you've probably banged your head against the desk dealing with them. So what are eggs? They are Python's prior de facto binary packaging standard. When I'm talking about binary packages here, in the case of both eggs and wheels, you could have a Python module that's pure Python code, and it'll package them up. There's not really any binary stuff in there. We're talking about Python packages that have C extensions, have to be compiled, and that are only going to work on the system that they were compiled on, or at least the operating system. These eggs had no official specification. They were just part of setup tools. Eventually what came about then was the wheel standard, when this is a new official format, has its own PEP. And one improvement that came with wheels is that they added this Python ABI tag. What this means is that you can have two different Python interpreters compiled in two different ways, and the wheels that are produced on one Python interpreter may not be compatible with another Python interpreter on the exact same operating system. That's what the thing in blue is. It's the ABI tag. So this is great. It's a necessary feature, but it wasn't implemented for Python 2. It was in Python 3, but not in Python 2. So there are some other things that Wheel did not solve out of the gate. And one of these is that the platform tag is underspecified for Linux. And when I say that, I mean the thing here in orange where it says Linux in the architecture, Well, what does Linux mean? There's a billion different distributions. I can guarantee that if you build a wheel on Ubuntu 14.04 and then try to run it on CentOS 5, you're going to have major problems. For this reason, Linux wheels have never been allowed in the Python package index in PyPy. There is an additional problem in that if you have a Python package with C extensions that link to system libraries, which pretty much anyone with a C extension is going to do, if the libraries that were linked against at build time are not installed on the system, the target system, when you install it, bad things are going to happen. Namely, when you try to start Galaxy, you're going to get a runtime linker failure and Galaxy is going to crash. So Wheel did not deal with these problems, so we wanted to solve them. To do this, we knew eggs were dead. We had to move to Wheel even though it had these deficiencies. So I started smashing eggs in the hackathon last year in Norwich. And one of the earlier tasks then was to implement Python 2 ABI tag support, which I said was missing. And thankfully, the work that I did there was upstreamed into both pip and Wheel. So that was crucial. But then I still had to address this problem of the Linux ABI and the dynamic linking. So for this, I went with a two-pronged approach. We've got platform generic wheels and platform specific wheels. So the ones I call platform generic wheels are just wheels that I built on a very old version of Debian, and it turns out pretty much if you build it on an old enough system, it should be compatible with all newer Linux distributions. But as a rule, then you can't dynamically link to any non-standard libraries. And what I mean by non-standard is anything that would not be part of a very basic Linux distribution installation. And for these, I just reused the old underspecified Linux tag. It's not a problem because these wheels are hosted on our wheels server. Pip will install them from there just fine. We're not uploading them to PyPy because these aren't our packages. For the platform-specific wheels, then, we're building them on the exact distribution and version and added this extra specificity to the platform tag. So for the Postgres library here, it's going to link against the vendor's version of the Postgres library. And this solved a couple of problems for us. One is that with the eggs, we did roughly the same thing, but I would statically link against Postgres, and it meant a very out-of-date Postgres that was missing a lot of features, especially like there was no SSL support in our egg for Postgres. With this, the vendor keeps it up to date, the Linux distribution vendor keeps it up to date, and the security is not a concern there, and so forth. Oop. So to do all of this, we repurposed Starforge, which was already a project in the Galaxy ecosystem. It began its life as a Docker-based build system for Galaxy tool dependencies, and then we added functionality to automate and make reproducible wheels. So this means that I was able to build those platform-specific wheels for 22 different Linux distributions, and also in OS X. And the great thing is that now it's trivially easy for anyone to add additional Python dependencies to Galaxy, even if they have these complex C extension wheels. You submit a pull request to Starforge, Jenkins will build it on our infrastructure, so that's it. Also, my favorite thing about Starforge is the logo. The amazing Eric Rashi did a little hammer, it's awesome. So right as I was finishing up all this work on platform-specific, platform-generic wheels, and I was trying to get it all upstreamed into the pip and the wheel projects, Challenger appeared. It's called ManyLinux, and they were solving the same problems that I was. And what they came up with was a single solution instead of the two-prong thingy. They built on CentOS 5. They explicitly defined that minimal set of libraries, which is good, because I hadn't done that. But also, here's the big thing, is that you are allowed to link to any kind of external dynamic library, but it has to be rolled then into the wheel and delivered with the wheel. So this was an officially accepted standard. They wrote a PEP, it was accepted. They wrote the implementations for pip and wheel. I worked actually with this to add some of the extra stuff, including the Python ADI tagging to many Linux. But there is one downside to these, and that's that now all of those libraries are, again, rolled back into the wheel. So people who are making wheels are responsible for updating for bugs and security and everything that's rolled on that wheel, and that's a lot of libraries, actually, because the minimal set of standard libraries is very small. So Galaxy 1601 and 1604, if you use them, use the platform generic and specific wheels with a modified version of pip that we were calling Galaxy pip, but in 1607, you will be using standard unmodified pip. You'll get the many Linux One wheels that we build with Starforge. And to try and deal with that security problem, where we have automation close to finished that will keep them up to date. But if you are interested in those platform-specific wheels, because I'm not totally sold over by the concept that the mini Linux came up with, please talk to me, because I'd be interested to hear about that. Okay, so we've dealt with the dependency problem. We can install them in a sane way. Now we want to be able to install Galaxy via the standard tool sets that system administrators are used to. Why was that difficult before? Galaxy made a lot of assumptions. So Galaxy has always been run from the source. You clone it, you cd to the Galaxy source directory, you type run.sh, or however you want to start it. You have to be in the source. And then Galaxy makes all of these assumptions based on that current directory being the source root. So it knows that the libraries, or the Galaxy library itself is in libgalaxy. The templates are in templates, tools and tools. All the static content is under static. So we had to stop making these assumptions, because in an installed world, you're going to install the package, all that stuff gets put somewhere on the system that you don't know about, and you're not going to start your Galaxy server from that location. There's also another bad assumption that was made, and that's that you could write into the Galaxy source directory, especially for things like the shed tool config. So I'll talk about the solution. So the solutions to these problems, I moved all the templates into the Galaxy package itself. So when you install Galaxy, it installs the templates and the tools. And as a result, then instead of assuming the locations of these things based on the working directory, you can find it based on where the code is. We've created a clear separation between config directories and data directories. So right now, you'll notice in the config directory, a bunch of files get written to, and then there are also files that you maintain. That's separate now. We added some scripts, since you won't have a run.sh, because you don't have that source directory anymore that you're working from. There's Galaxy Paster and Galaxy Config, which will create a Galaxy config file for you. You can pass it some options to change what's in that config file. So here's what it looks like. If you install Galaxy with pip, you can do this now. Pip install Galaxy. It's roughly the same as what you would normally do, but you add this index URL to install the wheels from our site. One thing to note is that many projects, especially like NumPy, have built their own many Linux wheels, but a lot of them have not. So we're packaging them. And then you get this huge mess, but at the end, hopefully, Galaxy should be installed, and you haven't had to manage any of these dependencies yourself. And there are no changes to the working directory. So you don't have a clone there that you're working with. You can run the Galaxy config command, get a config file in some directory of your choosing, and start up Galaxy and go from there. For system packages, it's very similar. You can add our repositories for apt or yum, and then yum install Galaxy, pip, or apt-get install Galaxy, however you'd normally do. But with system packages, we have a nice benefit in that we can claim a directory on the system, etc Galaxy. So now you can just have an etc Galaxy, galaxy.ini that you work with, and this is like a well-known, expected location for config files to live for a system administrator. That's the stuff in white is the output of the Galaxy config command, which gets run automatically when you install the package. All right, so now there should be mostly painless upgrades. This means you can pip install -u to get new versions of Galaxy. You can apt-get upgrade, yum upgrade, whatever. That means there should be a lower learning curve, especially for newer Galaxy admins. Don't have to learn this weird system in which we work, and hopefully more time for beer. All right, so what's left to be done here? All of this work is currently in pull request 921 on the main Galaxy, the Galaxy repository. So the target is to have this in for 1607 and start building packages that then you can install. They are a bit crude at the moment. They need refinement, so we'll work that out. If you're an admin, I probably wouldn't suggest installing 1607 this way, at least certainly not at first, but we'll get there. In the future, so we have apt, we have yum, Anaconda would be great. I don't know, brew, if you want brew, raise your hand or come talk to me or make it known, or any other packaging system that you might be interested in, let me know. Right now, we default those system packages to using SQLite, but that's no good. We want to default to Postgres. And then I had a project that I created early last year, maybe even the year before, called Gravity, which is a process manager for Galaxy based on Supervisor. It was its own separate project because integrating into Galaxy when Galaxy was run from source was very complicated and difficult. With the installed Galaxy now, it should be much easier, and then you'll get this Galaxy control command. So I'm going to integrate that with Galaxy, and then you'll have this command that can start up all of your Galaxy processes, UWSGI, handlers, whatever, the reports application, all of it can be run from there. And then I had a great conversation with Michael Caruso this week about getting the Galaxy package is upstreamed in Debian and Ubuntu via the Debian Med project, so we'll be trying to do that as well. So that is pretty much it. Thank you to everybody who helped me test and develop this stuff. And as well, the Python Packaging Authority and many Linux community members were all amazing in supporting this work. And then thank you, of course, to the Galaxy community and especially to my fellow Galaxy admins. Cheers. Thanks. Any questions?
The first one, thanks for the talk. What's the plus of using Gravity instead of Supervisor?
The plus of using what?
Gravity.
Oh, Gravity. Yeah, I don't want to have it be a separate project at this point. So I want all of that functionality just integrated straight into Galaxy. I think there's no reason to have it be separate. Does that answer the question? Yeah.
Can you give us an example of issues that you saw or that were reported when having non-standard areas or assumptions or directories?
Non-standard what? Sorry?
You were talking about like not assuming that it would be installed in the current working directory, for example. What kind of problems did you see?
So there are a lot of things like the default data types config file. There's a path in there about where are you loading the data type converters from, and it's /lib Galaxy data types converters. And that's not valid anymore if you're not running it from the source directory. So that's one. The shed tool config, it writes every time when you start Galaxy the first time, it writes out this blank one, but the shed tools get installed into /shed tools, which also, it's not valid. So that was where this idea of, okay, the configs that you write go into one directory that you control, and then Galaxy is going to just stick all of that other stuff, the shed tool configs, the installed tool shed tools, the dependencies, into its own directory that it controls.
You said you don't recommend that we just check out a brand new Galaxy via this mechanism for the next update. So should we expect more pain on this on 1607 if we were to do you know, a get pull and do our normal routine for existing instances? Kind of, what's the expectation for the next upgrade?
Yeah, so for the next, I mean, there's no time at which we're saying running from source shouldn't work, and that'll probably be the common way to run in development always, you know. So you should be able to continue running from source as you've always done. There's nothing should break there.
So we have a dynamic destination that we have a config file for, and it lives with the Galaxy config. Will there be an easy way for us to get the location of the new Galaxy config, and would you still recommend placing it within there?
Yep, yeah, there's an argument in the Galaxy config object which points to the config directory and the config file.
So we are going to have a Debian installation aptitude, install Galaxy, that's all, and of course install PostgreSQL, and that's all?
Yep.
Wow, that's for next, or for 8.5 and or for next one?
It's for the July release. Yeah, there should be enough components in there that are in there that I can start building packages on.
Anything about FreeBSD?
No, but if there is enough interest, then.
Or any Unix, no Unix interest. Okay.
I have lots of Unix interest, but I don't know about the rest of the Galaxy community. John says no. All right, thank you, everybody.